In this short video, I will describe how equalizing works. But first, the problem. The problem occurs when there's more bandwidth demand than there is supply. This typically happens when end users download large files, or these days, a more common and growing occurrence is when end users watch streaming video. With video requiring between 1 to 5 megabits per second, it doesn't take many streams before you have a bandwidth demand problem. It's pretty common for bandwidth problems to be created by a small number of users, usually between 5 and 10% of all users. However, this means that 90 to 95% of your other users are getting poor response times, or maybe even getting locked out. And this is happening for relatively low bandwidth needs such as email, web browsing, or voice over IP. To complicate matters more, when response times are slow, users will resubmit their requests by hitting the enter key many times, or refreshing their browsers, thus queuing up even greater demand. And of course, this happens when things are most fragile, and you can least afford additional requests and burden on your network. Inevitably, this leads to complaints and lost productivity, and if it occurs often enough, you may lose customers. Equalizing solves this problem. The NetEqualizer needs to be placed in a position where it can see all the traffic between the internet and your LAN. This is usually between the firewall router and your main switch. If placed here, it can see all the streams in your internet pipe. The NetEqualizer acts as a transparent bridge. If you were to look at the back of a NetEqualizer unit, you'd see two ports. One that leads to the wide area network, or internet, and another that leads to the local area network. All traffic, or internet packets, travel back and forth across the bridge. When your network is not oversubscribed, the NetEqualizer's equalizing function is in monitoring mode. In this mode, the NetEqualizer is listening to the traffic and monitoring how much bandwidth is being consumed in total and by all the unique connections. Because there are no problems, traffic passes just as you'd expect, normally. The NetEqualizer never looks inside any packets, nor does it ever modify any header information. While things are well behaved, the NetEqualizer is just passing packets at line speeds, and it adds no latency. However, this all changes when the pipe becomes in jeopardy of locking up. Let me start explaining how this works by taking you to the Active Connections report of the NetEqualizer. This is the Active Connections report available from the NetEqualizer's management interface. With this report, I can see all the traffic going through the NetEqualizer at this moment in time. Each row represents a current connection going across the bridge. A connection is a flow of bandwidth from a unique source IP to a unique destination IP. Depending upon your network size, you could have hundreds or thousands of flows at any given time. Keep in mind that the NetEqualizer only keeps track of current connections. It's not like a stateful router that keeps a connection active over many minutes. To the NetEqualizer, a connection is something that's happening now. If traffic stops flowing after several seconds, then the connection disappears and we no longer track the bandwidth usage. For each unique connection, the NetEqualizer also keeps track of the last 8 seconds rolling average of bandwidth. This number is in the column WAVG. As you can see, for each connection, some use very little bandwidth. These connections are probably web browsing, email, voice over IP, streaming audio, or web-based applications. We call these business class applications, and they comprise the vast majority of all connections. But if you look closely, you can also see there are a small number of very large bandwidth flows. These are most likely large file downloads, video chat, or streaming video. We call these bandwidth hogs, and they are the problem. They may be a small number of connections, but they use up a disproportionate share of the bandwidth. If your pipe has bandwidth to handle all these demands, then fine. The NetEqualizer monitors the traffic on the bridge as the packets pass as they normally would. But when the amount of traffic gets high enough that it poses a risk to the entire pipe, the NetEqualizer instantly switches into equalizing mode and will begin to slow down the large bandwidth streams in order to maintain room for all other connections, as well as potential new connections that may be established and need bandwidth in the coming seconds. To see how this works in greater detail, let's see how equalizing is set up. Here's the equalizing setup page. As you can see, there are a dozen parameters that can be adjusted or tuned. There are only 2 parameters that the user must input. That is, trunk up and trunk down, located in the middle of the table. Here you specify the up and down speeds in bytes per second of your internet pipe. Of course, you can modify or tune any of the other parameters to your specific needs, but the rest come preset as you see here. The ratio parameter, located on the top, tells the NetEqualizer at what point of pipe contention to engage actively. In this example, it's set at 85%. That is, when total traffic on the pipe is less than 85%, just pass all the packets as normal and monitor. But when the total traffic is greater than 85% of trunk up or trunk down, then become active and start slowing down the largest bandwidth flows. And large bandwidth flows are determined by the parameter hogmin, which comes preset at 12,000 bytes per second. Any flow greater than this amount should be slowed down by the penalty unit until the pipe goes below 85% total contention. Anything below hogmin will not be touched and will continue to pass at line speeds. This gives priority to the majority of users and all business class applications. Once the network comes under control and is no longer in jeopardy of locking up, then the penalties are removed. The network continues to operate like the NetEqualizer wasn't there, and the NetEqualizer goes back into monitoring mode. Since equalizing only distinguishes between large flows, or hogs, and small flows, or non-hogs, it requires no policy updates or ongoing maintenance. It also doesn't care what protocol or port any flow happens to be on. Because it only operates on behavior and does no packet interrogation, it is just as effective on encrypted connections such as VPNs as it is on unencrypted connections. The NetEqualizer is a turnkey appliance that monitors your network health 7 by 24 by 365 and is truly set and forget. And that's it. That's how behavior-based shaping or equalizing works. Perhaps at this point you were wondering, what if I have a large connection, say from a special server, and I don't want it equalized? How can I protect it? That we'll cover in the next brief video, Other Shaping Rules.